This video is all about getting more RPM out of your G0704 milling machine. So as you can see, I did a belt drive conversion on my mill, and I did the one, if you look at it, you can still use the high and low range on the milling machine. I made these 2-inch pulleys and got a really nice little belt and set this up. So I'm not going to really talk so much about the belt drive conversion in this video. That's something I'll put in its own video. I'm going to talk more about the bearing replacement in the G0704, because this belt drive conversion lets me get about 4,000 RPM out of the milling machine, and stock you get about 2,200 RPM, so you're pretty much doubled the RPMs. The first thing that happens is you notice the milling head here gets pretty hot. So those old tapered roller bearings, they have a lot more friction, so I converted it over to angular contact bearings. So that's what this video is about. And anyone who is into this stuff, anyone that's into these milling machines, these G0704 milling machines, has probably been to Haas's website and watched Haas's videos, and they're really good, they're very helpful. And I got my bearing information from him. So all the bearings and spacers that I purchased for this project, I thank him for that information and for being so kind as to share that with everyone. So there you go. So thanks for that. So I guess I'll get right into it. So conversion's done, and just a little demo here. So the angular contact bearings, getting about 5/10 run out of those things, and from what I can tell reading about it, that's about as good as they get. So I'm okay with that. I can live with 5/10 run out for the projects I do. That's going to be okay. And if I get rid of the mag indicator here, like I said, have this thing set in high-low range. So right now in low range, I can kick this thing up to about 2,100 RPM, 2,200 RPM in low range. So in low gear, I'm getting what used to be the max RPM for the machine, and when I put it in high gear, in high gear we can get 4,200, 4,300 RPM out of this thing. So that's a big improvement. I think that's really going to help this machine work a lot better. So I'll get right onto it. So this video, I'll try to organize it a little bit better than most of my videos. So if you're using it as a reference, it'll be easier for you to find what you're looking for. And I'll also put the part numbers for the bearings in the description of the video, so it'll be there if you need it. So okay, let me get on with this, and I hope you guys enjoy. Okay, so these first couple of parts, this thing, it just unscrews. There's nothing to it. Drawbar just pops out. This little speeder thing, plate, indexer thing just comes off with 2 screws. This thing here, a little weird. You actually have to push this down, and when you push it down, you can just slide this plate. So that's the little secret handshake there. Push this thing down, slide this plate. Okay, just pop the spindle out, and there it is. That's what it looks like. Pretty good stuff there. Kind of greasy, spring and all that, greasy. Don't forget to detach this thing before you disassemble your spindle. That'll be bad news if you don't. And this little guy right here is the little piece that goes up in the quill housing here that actually locks the quill spindle and holds it in position. So I'm going to take that out so I don't have to worry about losing it while I work on this thing. Okay, I am particularly proud of this. So this little locking nut that's down in here is really, I don't know. I've seen videos online where this thing comes right apart like no problem. Mine is tight. I don't have any kind of special spanner wrenches, so I didn't know what to do here. So got desperate, but came up with something. I found a couple of these little hooks laying in one of my drawers. Took it to the bench grinder, ground the tips down, bent it up a little bit, made it fit, and lo and behold, that thing went in there and did a phenomenal job. So I was able in about 5 minutes I was able to get this thing apart. So there you go, a couple pieces of aluminum, hold that spline shaft, get yourself a hook from Home Depot or whatever and grind it up, bend it up, and there you go, you have yourself a tool. Now we move on to this dust cap or this end cap or whatever this thing is at the bottom of the spindle. And once again, I do not have a proper tool to take this thing apart. So had a scrap of aluminum laying around, measured it. Those two holes need to be about 2.17 inches away from each other. Just drilled and tapped some holes for some M3 by 0.5 screws, notched out the middle of it, and that became the wrench to take that apart. Had a tap on it with a hammer to actually get it to break it loose. So it was pretty tight. So there you go. Not sure, I can't. Oh, there we go. That's the wrench, homemade. This took me about 10 minutes to make that, so still less than a trip to the hardware store. So there you go. Here is the end cap or dust cap or retaining cap or whatever this thing is actually properly called. I guess I could look it up in the owner's manual and figure that out. Pretty simple. Just wiped all the crazy blue grease off of it. There it is. And here is the spindle with you can see all the blue grease that's down there. So I tried to tap on this thing with a mallet, rubber mallet, and I cannot get it to come apart with a mallet, so I'm going to have to press it apart. Alright, so I just pressed the spindle apart, used the handy dandy little 12-ton shop press here from Harbor Freight. Worked pretty good. I have a couple little projects I need to work on, so I figured it was cheaper to just buy the little press, and I'll probably get rid of it when I'm done so I don't take up the space. But here it is. That's the spindle. Those are the bearings. This little screw will have to pop out of there so I can take the bearings off, but other than that, the pressed right apart. And now I got to get the races out of there, so let's see how much trouble that'll be. Alright, I was able to get the bearing races out without doing too much damage. I thought I was going to have to use a bearing puller, but as it would turn out, I was just able to tap on them with a piece of aluminum and a hammer, and I got them out without really doing too much damage to the housing. I probably could have been a little bit more careful, but I think we'll be okay. So So that wasn't too hard. So now I'm ready to really clean everything up really good and try to put those new bearings and new spacers in there. Here we have the new bearings. This is the what is this? This is the 707B, and I think this is the 705B. So these are the angular contact bearings. These bearings are a little bit thinner than the stock tapered roller bearings that come in the mill, so you have to space them out. So I decided to go with these spacers from McMaster-Carr. These are 35 by 45 by 1, and as far as I can tell, I'm going to need 4 of those to make up the difference. And then this other spacer is a 25 by 36 by 1.02, and according to my measurements, I'm going to need 3 of those. So that should take up the difference in the size of the bearings. So if you're interested, those items came from McMaster-Carr, those spacers, and that's how much they cost, and those are the part numbers. And while we're at it, there's the bearings from I think I got these from Bearings Direct. So there you go. Also got this Kluber ISOFLEX NBU 15. That came from CNC Specialty Store, and I think that was around $40 or $45 for that tube. Now I'm going to use this 3mm syringe with a 15 gauge blunt tip fill needle. That's what I'm going to use to hopefully put that grease in those bearings, and you can see that it's just about the right size. Just about the right size to get down in there and, you know, squirt the grease. So hopefully that's going to work out okay. So let me go ahead and do that. So this little needle actually works really good. So I can just sort of reach in here, and once I get this syringe to move, there we go. Just sort of go around and load up the grease here in between the bearings. I've heard different stories about how much grease you're actually supposed to use. I've heard a match head per ball bearing, so I'm just going to put a liberal amount in there and hope that if a little is good, then too much is even better. So there you go. Here is the stack up here, getting ready to press this in. So the 4 spacers right there, then the bearing. Don't forget to put this screw back in before you do it. And remember, these are angular contact bearings, so you got to make sure you're putting them in right. The side of the bearing with the wider gap where you can see more of the balls, that should be pointing that direction towards the open end of the spindle. And for these types of bearings, I don't know if all bearings are like this, but for mine, the numbers that are engraved on them, well, you can see the orientation, if that makes any sense. Okay, got that pressed in there and fitting pretty nice. I just gently ran that cap down just to see where it was going to end up, and looks to me like it's just about exactly where it needs to be. So That looks good. So now I'm going to move on to the smaller bearing that's on the other side of the spindle. So I thought I would try using the locking nut to seat that bearing, and it seems like it worked okay. I used my super duper high-tech tool here that I cobbled together, and just very carefully ran that thing down. I would turn it a little bit, then back it off just to make sure everything felt good, and kind of went until I couldn't really turn it anymore. I figured that must be you know, the bearings at the bottom of the seat, or seat at the bottom of that bore. And then as far as the preload, I can't figure out how much preload you're supposed to have for these things. So I just gave it a good, you know, one good healthy snug here with my tool, and hopefully that'll work. Hopefully it won't be too much. There it is. So now all I have to do is put the 2 locking screws in, and then I have to turn it around and snug up that dust cap at the other end of it, and then we'll see what we have. Now it's time to get that thing out of there. So I got a little setup here that I'm going to use. So I found a piece of all thread, and I'm going to take this piece of all thread, I'm going to slide it up through the spindle, up using some parts here from my hold down kit and some chunks of aluminum. So I'm going to basically stack all this up and put that all thread through the spindle up through there and use it to pull those bearings out. So let's give it a shot and see how well that works. Okay, this thing's working pretty well. It's kind of hard for me to turn it and film at the same time, but I had to put two of these things together up here and lock them down, so I can put a wrench on there and keeps the whole shaft from turning. And then I just turn this nut with my wrench, obviously. I put a little grease or oil on everything, and you can see this is bearing is starting to rise up, pull out of there. It's in there tighter than I thought, and it kind of, you know, I tighten it up, this thing loads up a little bit, and then all of a sudden it just, it'll pop up out of there. But it's working, and I'm pretty happy about that. So let me go ahead and turn it the rest of the way out of there and see if we can get those bearings off. One thing I got to make clear, point out, while you're pulling this thing apart, got to make sure, see if I can get a shot right down in there, you got to make sure that your gears are lined up. So you may have to go back and forth between high gear, low gear, neutral, or whatever, but you want to make sure that while you're pulling that assembly upward, that you're not messing up the plastic gears that engage with it. So just pay attention to that while you're pulling that assembly out. Okay, finally got that assembly out of there, and this is what the inside of that housing looks like. And you can sort of see here how this little shift fork just raises those plastic gears. Yeah, they're plastic. Up and down on that intermediate shaft. Piece of cake. Nothing too fancy there. And over here, you can see this is the bearing assembly, the little, you know, the splined housing that the spindle rides up and down inside of, and there's the makeshift bearing puller. Worked great. So let me get these bearings off of there and pop new ones on. Alright, here's a quick little tip. So if you have the same little Harbor Freight snap ring tool that I have, what you'll find immediately is that this snap ring tool out of the box does not have enough travel to get this big snap ring off this assembly. So that's kind of annoying, right? It's, what do you do? So if you take the little pieces and just use them like this, they have a lot more travel. So what I did was, instead of using the handle, I just inserted this thing into the snap ring, and I used a screwdriver to prop it open, and I got it spread far enough that I could just get it out of the groove, and then I could use the screwdriver to pry it up the rest of the way. So there's a little, I don't know what you want to call it, a little tip, I guess. Use your headpiece, your attachments without the handle, and use the screwdriver to pry them apart. So here is my setup here on the arbor press to press this thing apart. This is totally shaky and suspicious, but it works. The only thing I could find was thin enough to fit in there. I pried this bearing off just a little bit with some screwdrivers just to make a little gap. And the only thing I could find that would fit through there was some pieces of aluminum extrusion. Of course, I couldn't get it to all stay together, so I had to put some clamps around these pieces, these vertical pieces, and it just barely works, but it gets the job done. So a little shaky, but it is what it is. And on to the next step. Well, finally got those bearings off of there, and it doesn't surprise me that they were hard to take off. It's kind of all gunked up and rusty or whatever under there, but I finally got them off. So getting those bearings off would have been impossible if I didn't have this little hydraulic press. And in addition to the hydraulic press, you need to just have like all kinds of little pieces of junk and stuff, washers and spacers and screwdrivers. You just constantly like trying to find something you can wedge in between the little open gap there that you have. So I started out prying those bearings off with screwdrivers and bars, and then once I got a big enough opening, I threw washers in there and put it in the press, and when I got a little bigger opening, eventually I worked up to these screwdriver shafts. But you'll see when you go to press them apart, you just need a healthy supply of odds and ends and bits and pieces to keep working with as you're pressing those bearings off. Here are the new bearings, and these, as far as I can tell, these are a like for like replacement, so they're the exact same size. They don't need spacers or anything like that. And I believe these bearings, I don't think it matters which way you install them, as far as, you know, I don't think they're not like the angular contact bearings where there's a certain orientation. I think these you just pop on and go for it. So clean this up. I'm gonna smear a little oil on this assembly. Then I'm going to go back to the press, and I think putting the new bearings on is going to be a lot easier than taking the old bearings off. So here we go. Well, as I suspected, it was a whole lot easier to put the new bearings on this thing than it was to take the old ones off. So here it is. It's ready to go back in the spindle head. One little trick, I did not have the right size snap ring or whatever retaining ring wrench or pliers for this thing. So when I put it in, I just sort of start at one end in the groove and just used the screwdriver and just worked my way around, and it popped in. So that's probably common sense, but if you've never done it before, that's a helpful little tip. So I'm going to clean this thing off, grease it up, and maybe grease up the inside of that thing and put some oil down in the bores where these things are pressing, and then I'm going to try to put it together. Alright, so I am reinstalling the bearings here in the top part of the spindle housing. So what I had to do, before I could use my little bearing drawbar type of rig here, I had to just manually start tapping on this bearing with a piece of aluminum and a hammer just to get it started, because this bearing starts before this one down here starts. So you have to get this one in alignment. You have to make sure that this bearing down here starts in its bore correctly, and you have to make sure that your teeth are meshing. once you have the bottom one started, then you can set up this little rig. And once again, all I did is I have a piece of all thread that I'm using through one of my hold down clamps, and I'm using the old bearing and some spacers. So I did that because I want to put the force on the bearing. I didn't want to put the force on the metal part of the spindle and then push on the snap ring and then push on the bearing. So I wanted to push right on the bearing. I didn't want to put the force through the snap ring onto the bearing. So that's why I have this little assembly here of junk and spacers and whatnot that I found laying around. So that's going well. So I'm going to crank that down and get that thing in there.